In our next section, we're going to look at the spanning tree implementation in JunOS and specifically talk about how rapid spanning tree is used and how multiple spanning tree can be used, and then how that is going to interoperate with Catalyst iOS implementation per VLAN spanning tree by default. Now, in JunOS, we essentially have two different variations that we can run for spanning tree. We have the original legacy protocol, which is going to be defined under protocols STP, and then we have the rapid variation that is going to be defined with protocols RSTP. Now, depending on the particular platform and the specific version, you may see sometimes you're running protocols STP by default, you might be running protocols RSTP by default, but in general, in a real implementation, you would want to be running the rapid variation. But one of the key differences here versus Catalyst iOS is that regardless of whether we're running the legacy protocol or the rapid variation, we're only running one instance for all VLANs. So this means that when we go to interoperate with Catalyst, there's going to be some issues because Catalyst is running normally the proprietary version of either regular spanning tree but on a per VLAN basis, or the rapid variation on a per VLAN basis. So likewise, in the Cisco world, depending on the particular platform, most of the newer boxes only support rapid PVST. For example, Nexus and some of the newer Catalyst lines, they're going to also be running RSTP by default, but they're going to be running it on a per VLAN basis. Now, one of the reasons why this is an issue is that when the Catalyst goes to send the BPDUs for spanning tree, basically the hellos and the keep alives, only one of the VLANs is going to be encoded with the MAC address that the Juniper switches is listening for. So what we basically would run into, and if we take a look back at our physical topology, that if we are running, assuming we're doing layer 2 trunking, we're doing layer 2 trunking between the EX switches and the Catalyst switches. When the Catalyst switches define the different VLANs, let's say, for example, we have VLANs 10, 20, and 30, normally by default, they're going to have separate instances of spanning tree for these. Now, when they actually go to send the hellos, they're going to be encoded as a vendor-specific multicast address from a layer 2 point of view, and the Juniper switches are going to treat that as any other normal link local multicast and go ahead and forward those packets on. So the end result would be is that even though the spanning tree messages do get carried over the JunOS switches, the topology ends up to be wrong, because it essentially the devices in the middle, like in this case, the Catalyst switches would not know that the Juniper switches are there for other VLANs beside VLAN 1. So we're going to take a look at this first, just doing the basic configuration between the EX switches, and then look at what happens when we introduce the Catalyst switches and what are some of the ways that we can work around this. So let's take a look at then on the links that are connecting EX1 and EX2, which are going to be our Gig E6 and 7. And also there's additional links. I'm going to shut them down for now, and then we'll look at a little bit later what happens when we turn up those ports that connect to the Catalyst. So on EX switch 1 here, I'm going to go to config mode, and I'm going to set interface Gig E0023 disable, which again, that's the equivalent of the shutdown command in iOS. Then on EX2, I'm going to configure, and we'll set interface Gig E0022 disable, and 0023, and we'll commit. Okay, commit and quit. Okay, once we're back to operational mode, let's go ahead and exit out of there. And let's check the status of the trunk links between them. So we're going to show Ethernet switching interfaces, and we're going to show interface Gig E006. And again, this is showing us essentially that this is a .1Q trunk because there's multiple VLANs. It says what are the particular VLANs that are in the allowed list, and then whether spanning tree is forwarding them or blocking them. So again, remember with trunks in JunOS, by default, they don't send any VLANs. You have to manually set the allowed list, or essentially the VLAN membership list in the case of JunOS, to say what VLANs do we want to forward. So if you were to verify this and you don't see any VLAN members, it's because you didn't manually specify them. And from a configuration point of view, if we show config interfaces Gig E006, We can see that's defined under family Ethernet switching, which again means that it's a layer 2 port, and then specifically it's a trunk port that's carrying all VLANs. Now from a spanning tree point of view, if we show config protocols, so both our layer 2 and layer 3 protocols are going to be defined here under protocols, and in this case we have rapid spanning tree protocol running. Now on some of the other boxes like the SRXs, if we look at the show config protocols, these ones are running regular spanning tree by default. Essentially this box is kind of like an ASA 5505 in the Cisco world, where it's a firewall with routed ports, but it also has a layer 2 switch built into it. And in this case, that layer 2 switch is running legacy spanning tree. So if you were to use this as part of the rest of the switch network, you would probably want to disable STP and then enable RSTP. And the way we would do that is to go to config mode. We would edit protocols. And if we show under here, we can see we have STP. We would delete STP, and then we would set RSTP. And if we show pipe compare, it says that we're going to turn one protocol off and we're going to turn the other one on. Okay, if we were to try to, well, let's say we do that on SRX2 and we show config protocols. We go to config and we set protocols RSTP, and we try to commit and quit now. Once it goes through its checks, it's going to tell us you can't do this because we can't run both the rapid variation and the legacy variation at the same time. It's going to be one or the other. Now, in the case of the Cisco world, we would go to global config and set the spanning tree mode. And when you set the mode, it's automatically going to override what was previously there. So most of those switches, if we look at, for example, the Catalyst 3560, and we say show spanning tree, normally they're going to be running per VLAN spanning tree, which is what they denote here as spanning tree enabled is IEEE. If we were to show run pipe include spanning tree, so spanning tree mode is per VLAN spanning tree. So for this particular Catalyst platform, the options are PVST, RSTP, which actually is rapid PVST, and then multiple spanning tree protocol, which is going to be rapid spanning tree, but we manually define what particular instances are going to map to the VLANs. Okay, so next, once we have spanning tree on, so you can see it's running by default. If we look at the show spanning tree bridge, that's going to be basically the instance. And this is going to tell us some generic things about the state of the protocol. Okay, the most important thing really that we're looking for here is what's the root identifier. So since spanning tree is a standard, the rules for bridge election, the rules for path selection don't change between JunOS and Cisco. So we're looking at the lowest bridge ID, which is made up of the priority and the MAC address. And then if we want to change the root bridge election, we're either going to lower the priority value or we're going to raise the priority value. So we can see in this case it says that the root ID has a priority of 32.768. This is the particular MAC address that's making up the bridge ID. My local bridge ID is 32.768 and then this MAC address. Or in other words, it means that this box is not the root. If we were to go over to the other switch, EX2, which if we look at here, it says the root port is gig E003. And if we look at this in our particular topology, gig E003 is actually this link here that's going down to SRX2. So keep in mind that even though the SRXs are routers and they're firewalls, they are running spanning tree on the interfaces that are in switching mode. So as long as we're saying family Ethernet switching on them and spanning tree is enabled globally, it means that those ports are going to participate in spanning tree. So to simplify this a little bit, I'm just going to disable those other interfaces. So let's basically say any of the links that go down to the firewalls. So gig E000 through 5, I'm simply going to disable those. Okay, we could also do this in one step like I was talking about yesterday by defining an interface range. So if we go to config mode, let's say we're going to set an interface range. We'll say that this is to SRX. Okay, that's the name we're giving it. And we're going to set what are the members. Actually, we'll say the member range. Member range is going to be gig E000 to gig E, do we say 0 to 5? Missing or invalid port number. Let's just say member. I'm not 100% sure what the exact syntax for that range is. Gig E000, 1, 2, 3, 4, and 5. Okay, so if we show this config, let's say show interfaces. So we can see now we have a range that's made up of these particular ports. Then if we commit this, and we'll do the same thing on the other side. Let's say show interfaces pipe display set. So copy this to the other switch in config mode. And then on that interface range, we're going to say set interface range to SRX disable. Commit and quit. Okay, so this is essentially the same as in Catalyst, going to global config, saying interface range, defining the ports, and then issuing the shutdown command. The difference, like I mentioned though, is that in the case of Catalyst, that's just an on-the-fly configuration. You're not defining a macro for the interface range by default. In this case, in JunOS, this is persistent. So anytime we want to come back and reference the range, it's always going to be defined there under this variable that I'm saying, which is 2_SRX. In the case of Catalyst, this would be more similar to doing something like this, where we would say in global config to, or actually I think it's in exec mode, to define, and this, is it macro define? I'm not sure if this version has it. Macro auto config, let's try global. Macro global. I think this version doesn't specifically have it, but in some versions, basically, you can define an interface range like this, give it a name, and then when you want to come back to it later, you can reference that particular name. Okay, but otherwise, as far as I know, there's not really another shortcut to do this, other than specifically listing the interfaces. Okay, so now if we look at the show interfaces terse, which again is a similar equivalent to show IP interface brief. What we're looking for here basically is that these links are admin down. Okay, so these links are now in the shutdown state. So same thing on EX2, let's say set interfaces, interface range to SRX, disable. Okay, also notice if I do a tab there, if capital T and then a tab, that does do completion. If I hit spacebar, spacebar does not complete it. And again, that's the difference between when you're doing the auto completion. Tab is automatically going to complete the variable names. Space is only going to complete the regular syntax keywords. So if you're already used to doing tab like in iOS, you can continue to use tab, and then it's going to do completion for both of them, both for the variables and for the syntax names. Okay, so we will disable that interface range, commit and quit. Okay, now back at the switch, if we look at our spanning tree options again, so let's say show spanning tree, bridge. This is talking about our first instance, which is instance number 0, okay, or what they call the context. And we can see now it says the root port is gigi 006. So from our physical topology point of view, gigi 006 is the link that goes over to EX2. So this device should be the root bridge, simply based on the fact that it has a lower MAC address. So if we look at here on EX2 and say show spanning tree bridge, we should see that the root ID here is equal to the local bridge ID, or in other words, I am the root bridge. Okay, this particular switch is root. So again, if we wanted to modify these parameters just like we would in Catalyst, we could take the bridge ID and change the priority up or down. We could go to the port level and change the port cost. We could change the port priority, and then those are going to affect how the tree is ultimately built. The difference, though, is that from a configuration point of view, this is going to go under protocols RSDP, and effectively what's the global config of JunOS, as opposed to in Catalyst. Normally those options would go at the interface level if we're changing like interface spanning tree port cost, for example. So in our particular case, if we wanted to say that EX1 is the root bridge, the way that we would do that is go to global config or just configure mode, and we would edit protocols RSDP, and if we set and look at the question mark, what are the options that we can change to affect the root bridge election? It's going to be based on the bridge priority. So it says in increments of 4K, technically it's not increments exactly of 4,000, it's increments of 4096 because that's based on the number of VLANs. But when you look at this in the Catalyst implementation, Catalyst you have to specify exactly what the priority is. For example, if we said spanning tree VLAN 1 priority 1, it says you can't do that. You have to do it exactly in these ranges. JunOS simplifies this a little bit, where instead of saying 80, 90, or 81, 8192, it just says put 8K, and we know really that it means 8192 because it's 4096 times 2. So if I were to say that the bridge priority is 8K and then commit, and if we look at EX2 and now look at that same command again, which is show spanning tree bridge, we see now the root ID changes. The root bridge now has a priority of 8192, and it's located out port GigE 006. Okay, additionally, if we look at the show Ethernet switching interfaces, and if we look at GigE 006 and GigE 007, we should see, so let's say, for example, show Ethernet switching interfaces pipe find GigE 006, that's the equivalent of begin. We can see that on port 7 is being blocked by spanning tree. So in normal spanning tree rules where we can only have active standby, we can't have active by default. So we're going to find what's the lowest cost of the root bridge. That's going to be the root port. Then any other upstream interface is going to go into the blocking state. Then any of our downstream interfaces are going to be either designated forwarding, or they're going to be backup blocking, or potentially alternate. But we can see this just by looking at show Ethernet switching interfaces. It's essentially the combination of show interface trunk in the case of Catalyst, and also the show spanning tree. Okay, we could also look at the details here if we were to say show Ethernet switching interfaces GigE 006 extensive, or not extensive, actually in this case detail. This also tells you what particular instance of spanning tree do those individual VLANs belong to. And we can see by default everything belongs to instance number 0. Now from a Catalyst point of view, if we were to now go to let's say the 3560, which is over here, and if we were to activate, let's say for simplicity we're going to activate just one of the links to start, and we should also already have these particular VLANs configured. If we look at the Catalyst and say show VLAN brief, we see that the VLANs do exist and they're active. On EX2, likewise, if we were to, same thing actually, show VLAN brief, we should see that these VLANs do exist. And if we then enable one of our interfaces, so on the Catalyst side, if we look at the show run interface F02, and that's the link that goes to EX2. And on EX2, we're going to go to config and say set interface GigE 0022. Actually, let's say run show interfaces terse, actually GigE 0022 terse. Okay, so we can see right now that's in the admin down state. That's because I had set the interface disable, where in the case of iOS we would say shutdown or no shutdown. In the case of JunOS we set disable, or in this case if I want to enable the interface I delete disable. Because now disable is one of the properties under the interface. If we look at the show interface is GigE 0022, this is going to be not under the family because it's not part of the protocols, it's going to be a physical function of the link. So if I wanted to enable the interface, I would set interface GigE 0022, actually not set, excuse me, delete. delete the interface, disable. Okay, that's going to activate the interface. Okay, then we'll commit and quit. Okay, once the link comes up, we should see on the Catalyst side that we get a log message, a syslog message that the interface is going to come into the upstate. In the case of JunOS, if we want to in the case of JunOS, assuming that we want to turn a logging on, we would do this from operational mode, and we say monitor start messages. Okay, messages is basically just the general logs. Now, there are obviously more detail that you can get into here, doing different debugs, similar to how Catalyst debugs work, but in the case of JunOS, normally they're going to be written to a file. In this section, we're really not going to get into the details of that because that's going a little bit too low level into the protocols. But you can define, like for example, if I wanted to do logging for spanning tree, that would be under the particular protocols, and then we would define that as the what they call the trace options. So we would go to global config and then edit protocols. Okay, you can see we have the log messages now, and we would set the edit RSTP and set the trace options, set the trace option file, and then basically this is the equivalent of doing a debug spanning tree in the case of Catalyst. And then you can either, we could read the file in real time, or we could just wait to collect it and then turn the trace options off, and then basically we have the file written to flash. Okay, so now once the interface is up, okay, we see Catalyst gets the log message. Let's, on the Catalyst side, look at the show spanning tree. Show spanning tree interface F02. Okay, it says that for VLAN 1, this is the root port. But for all of the other VLANs, the interface is in the designated state. Now, if we were to do this on the ME3400 as well, so let's go to the other side. And we'll say on this link here, which is on EX1, we're going to say on EX1, we're going to say, go back to the top of the root, and we're going to set interface as gig E0023, actually not set, delete. Delete interface as gig E0023, disable, and commit and quit. So again, that's the equivalent of no shutdown. And once this comes up on the ME side, so we should see gig, or not gig, fast Ethernet 23, we should see that port come up, which it does. And also let's turn logging on again here, which is going to be the monitor start messages. So from the ME side, if we look at the show spanning tree interface, and the particular port here is FA023, notice that we kind of have a mishmash of what the particular roles are of the ports, where it says that for VLAN 1, that's the root port. For VLAN 12, it's the root port. But for some of these other ones, like 10 and 20, these are designated ports. Basically, this is an indication that we're not agreeing on the spanning tree topology with the JunOS switches. Because the only instance that we're interoperating with by default is VLAN 1, because the MAC address for the spanning tree BPDUs of VLAN 1 matches up on the Cisco side and the JunOS side. Now, if we were to look at one of the other ones, let's say, for example, VLAN 23, and we show spanning tree VLAN 23, it says that the root bridge is 32.791 with this particular MAC address. Okay, if we look at the Catalyst 3560 and do the same thing, show spanning tree VLAN, and that was VLAN 23. Notice this value here, 3580, is the same one. So in other words, what's essentially happening is that the PVST messages that the Catalyst is sending to the EX switches is essentially getting tunneled over it and then coming back out the other side. But the reason that this is an issue is that if there's multiple links in the middle, we're not able to tell the difference between one versus another. So we do have the potential to cause a loop in the network because we're not doing the calculation end-to-end between the JunOS switches and the Cisco ones. Now basically there's two different ways that we can fix this. We can, on the Cisco side, collapse all of the VLANs down to a single instance of spanning tree. And the way that we would do that is to go to global config and say spanning tree mode is MST. And what this is going to do is going to create MST instance 0 for us. Show spanning tree. But we can see now we get an error message that says blocking the port because there was an inconsistent inferior per VLAN spanning tree BPD received on VLAN 12 claiming to be the root bridge. Essentially, this was the ME switch on the other side. So we need to make sure to do this on both sides, which is spanning tree mode MST. This has to do with an issue in interoperability, that if you are running multiple spanning tree and other variations, the root bridge, which is called the regional root bridge, has to be within the multiple spanning tree domain. So if we simply just say spanning tree mode MST on all of the Cisco switches, they're then going to start running just one instance of spanning tree, and then this should map on a one-to-one basis with the default behavior of JunOS. So once the links are actually activated, let's go to the CAT 3560, and actually it did it itself. It says the inconsistency was cleared. If we look at show spanning tree now, and we compare this to the EX switches, show spanning tree bridge, EX1 is the one that we modified the priority on. So it says the root ID is 8192, MAC address is 3C61, etc. This is the one that matches up with what the local bridge ID is. So if we said show spanning tree bridge, pipe match ID, we can see these two fields are the same, so I am the root bridge. If we look at this from the Catalyst side, and assuming that we see this value matching for MST instance 0, we can see now the spanning tree domain is end-to-end. That they're agreeing, essentially the Catalysts are agreeing that the EX switches are the root bridge. Now, the other way that we could fix this, though, is to actually run multiple spanning tree and define the instances. That would be if we did want to run multiple instances depending on the individual VLANs. And the way that we would do that is going to be under the under protocols under multiple spanning tree, and then we would define, similar to what we would do in iOS, we say what are the instance numbers, what are the particular VLANs that map to those instance numbers, what's the name in the revision, then assuming all of those parameters match, we're in the same region for multiple spanning tree, and then we would be able to do path selection on a per instance basis. But again, the point being here is that in JunOS, assuming they're running rapid spanning tree, they're only running one instance of this, so it's not automatically backwards compatible with Catalyst per VLAN spanning tree. So a simple solution in the Catalyst world, just say spanning tree mode is MST. That's going to collapse everything down to MST 0, and then they will be able to run spanning tree together. Now, if we did want to define the multiple instances, in the case of JunOS, likewise, this is going to be under protocols. So if we go to config mode, if we edit protocols, and we set, instead of setting RSTP, we would be setting multiple spanning tree. So we're going to delete RSTP, and we're going to edit MST, or MSTP. Okay, under multiple spanning tree protocol, then we would set our revision level. Okay, so that's basically a number, like 1. We set the configuration name. We'll call this JunOS to iOS. And then we would set the multiple spanning tree instances, the MSTIs. What's the ID? For example, we have instance number 1. And then what are the VLANs? So if we say run show VLAN brief, we have our particular VLANs here. So let's say we're going to split this into 3 separate instances that will say, so let's see, how many do we have total? We have 13 different VLANs, so let's say we're going to split them here. Okay, we're going to say that we have set MSTI 1, so we're creating instance number 1, and then the VLAN members. So we can either do this individually, like I could say VLAN 12, VLAN 23, VLAN 24, etc. Or we could do it as an ordered set. So we could say set MSTI 2, VLAN, open brackets, VLAN 34, VLAN 35, etc. Do it all in one line. Okay, then if we show, we can see the end result is that it becomes this ordered set anyways. If we show pipe display set, we can see what are the set commands that we're actually using to make the config changes. So let's say that we take this, and then I'm going to paste these as the split for our VLANs. So we'll say set protocols, MSTP, MSTI 2, VLAN, and then the VLAN IDs. Okay, and then the other set protocols, MSTP, MSTI 3, VLAN, and then the name. So as you can see with JunOS, it does really come in handy to have a separate text editor to edit the configs, simply because unless you drill down into the individual hierarchy, when you want to change a lot of things, it's easier just to paste the entire set command in. Okay, so we're going to agree on this on both switches. Now, just like in the case of, and I need to go up one level, I believe. Let's see where I am. I'm under protocols, MSTP. So let's go to top, and then we can paste those in. Okay, if we then show protocols pipe display set, actually let's say show protocols, show protocols pipe display set. We'll take this and paste it on the other EX switch. Then we're going to delete protocols RSTP. If we show pipe compare, what this should show us is that we are removing the rapid spanning tree config, and then we're adding the multiple spanning tree. Now, when we look at the output this way, as comparing it to the set commands, the hierarchy is much easier to read. That we can see that we're running multiple spanning tree. Globally, we have 3 different instances, and then what are the particular VLANs that map to the instances. Now, just like in the Catalyst world, if we have other VLANs defined that we don't manually map them to instances, those fall back to the common internal spanning tree, which is MST instance number 0. Okay, so let's commit and quit. On both sides here, commit and quit. Then on the Catalyst side, we're going to configure this similarly. So we will say globally, spanning tree MST configuration. The name was JunOS to iOS. The revision was 1, and then we have our instances. Instance 1 was these particular VLANs. So let's do it this way. This would be spanning tree MST configuration. The name was JunOS to iOS. Revision was 1, and then we have the instances. So instance 1 was VLANs 12, 23, and 24. Instance 2 is VLANs 34, 35, 36, 45, 46, and then those other ones. So really the disadvantage of this is that you have to make sure that this configuration is 100% equal on all of the switches, because otherwise they end up to be in different regions. So from a real design point of view, it really depends on how complicated the spanning tree topology is. If you don't need to do path selection from a layer 2 point of view, the easiest way to solve this is just run one instance of spanning tree. So you could just turn, like I said, you could turn MST on, and then the iOS side is going to agree with the JunOS side, and then unless you're doing some complicated traffic engineering at layer 2, you don't really need to define the different instances. Okay, and we can see that now once I'm changing the config on the Catalyst side, we can see that's affecting the spanning tree election. Okay, on the Catalyst side, if we say show spanning tree MST, we can see that the other VLANs that we do not define, those are going to fall back to instance number 0. So let's say, for example, we look at MST instance 1, and on ME3400, let's say spanning tree MST1, my priority is 4096. When we look at this from the JunOS side, if we now show spanning tree bridge and the MSTI instance number is 1, we should see that the root bridge is 4096 plus the instance ID, which is the system ID extension for a spanning tree. It's basically the instance number encoded there in the bridge ID. But if we look at the particular MAC address that is the root bridge for this particular instance, this 2B80, and then on the Catalyst side, say show spanning tree MST1, it says my bridge ID is 2B80 and I'm the root for this instance. This is the way that we verify that the spanning tree is end-to-end, is that they're agreeing on the topology, that essentially we agree on what the root bridge placement is. Okay, so if we look at this final config on the JunOS side, we'll show config protocols. And again, that's configured under either STP, RSTP, or MSTP. We can also see that under protocols, we're running link local discovery protocol, or the link layer discovery protocol. This is the open standard equivalent of CDP. So if you want to make sure you know how the network is physically wired, then that would be a good idea to turn on both on the JunOS side and on the iOS side. So in the case of iOS, we would go to global config and just say LLDP run. And that should just be enabled on all the interfaces then. LLDP run. Then if we show LLDP neighbors, we should see that we start to become LLDP adjacent. Now on the Cisco side, if we show LLDP neighbors, it doesn't know the details of all the encoding. This really depends on what particular version that you're running. Like one of the shortcomings of this, it says that I am LLDP adjacent with the EX switch, but the remote port, I don't know how to encode this as a name. So we would have to correlate what is port number 548. And I want to say that this is the SNMP interface index number. So on the EX2 side, which is this guy here, and we say show, let's see, what is the wiring here? Let me look back at the physical topology. So port number 2 connects to 22. So let's say show interface is GIGI0022 extensive, pipe match, and then Catalyst said the number was 548. It's the SNMP IF index number is what it is. So you can still correlate this. It's just that from the Cisco side, you can't tell what it is by default. You'd have to go to the other side and then search for what link has that IF index, and then you would know how the ports are physically wired. But from the JunOS side, we can see when we show LLDP neighbors, they can decode what the naming convention of the Cisco port numbers are. Because as we can see here, the naming convention is different, where Cisco uses like FE or gig. In the case of Juniper, it uses FE, GE, XE for fast gig, 10 gig E, and then the dash is there. I think it's the dash actually that iOS has a problem in the encoding with the LLDP. There's a question here, is there anything that needs to be configured additionally in order to make the EX switch as the root? We would just change the priority for that particular MST instance, the MSTI. So let's say, for example, we want switch EX2 to be the root bridge for instance number 2. We would go to config. Actually, so let's say first show spanning tree MSTI2, bridge MSTI2. Bridge MSTI space 2. And we can see we're not the root bridge. Okay, if we look at that, let's say show that, and we'll pipe match ID. Bridge ID, and let's say root or pipe match ID, pipe match root. Well, we could see here in either case, without doing the pipe, these are two different values. Or in other words, this switch is not the root bridge for that particular instance. If we did want to configure it, we would go to config mode. We'll say edit protocols, MST P. We're going to edit MSTI 2. So now we're under the instance. And we'll say set the bridge priority. And we'll set it to a lower value, like 16K. Commit and quit. If we now go to the catalyst side, let's say like the 3560, and show spanning tree MST2, we should see the new root bridge now has the priority of 16,000, or specifically 16,386. If we check on the EX side, show spanning tree bridge MSTI2, we should see now the root ID and the bridge ID, these are matching, so I am the root bridge. Okay, the other options that we have in spanning tree similar to Catalyst is that we would configure normally the edge ports, because in the case of edge ports, those are the ones that are not subject to the forwarding delay, and it also affects how do we do the synchronization process and can we do rapid convergence. So when a link comes up, if it's configured as an edge port, we don't need to synchronize, we can immediately send it into forwarding state. And also, if that link flaps, we do not generate a topology change notification, which means we don't have to clear out the CAM table, the MAC address table. Where in the case of Catalyst, we configure this with the spanning tree port fast command, or if this was Nexus, this would be spanning tree port type edge, or spanning tree port type edge. In the case of JunOS, this is under protocols RSTP, or under MSTP, depending on what instance we're running, under the interface under that process, and then we simply say set edge. So for example, here, if we were to look at the show spanning tree, actually let's say show interface terse pipe exclude, no, except down. And let's say port number 20, well, let's actually enable an interface. Let's say config show interface gig E000. Let's set interface gig E000, no, not set, delete. Delete interface gig E000, disable. Which, actually I'm on the wrong switch, EX1. Show config, interface is gig E000. Oh, you know what, it's disabled under the interface range. So I need to delete interfaces, interface range, the name, which is 2SRX, delete interfaces, interface range, 2SRX, disable. Okay, that's bringing the interfaces back up. Now, once the interfaces do come up, let's show interfaces terse, and I want to see this first port. This is going to one of the routers on the other side. If we show LLDP neighbors, or run show LLDP neighbors, that port GIGI000, that should go to SRX1 on the other side. Okay, if on the SRX side, that's not running LLDP by default. The switches do, but the routers don't. You can turn it on. That would be under set protocols, and we simply say we would set protocols LLDP interface all. Commit and quit. So then when we show run show LLDP neighbors, eventually once this converges, we should see that the router and the switch are adjacent on their port. But what I want to show here within the scope of spanning tree is that if we, let me exit out of here, let's say show spanning tree interface GIGE000 detail. This is a it's a point-to-point edge port that's currently designated, and the way JunOS does this is kind of similar to the way Catalyst does. That the link comes up, we send the rapid spanning tree synchronization to ask the other end of the link, do you want to run rapid spanning tree? If we don't get a response back in, it means that either the device is not running spanning tree, so like it's an end host, or it's running the legacy variation and it doesn't understand the synchronization process. But when that happens, what the switch has to do is to say, well, I can't guarantee that the device on the other end of the link is running rapid spanning tree, so I'm going to fall back to the legacy spanning tree rules. Now, if we were to actually debug this and look at the timers, we would see that when this link flaps, it doesn't immediately go into the edge state. It's only once the switch sends out the synchronization, so it's part of the proposal process, it doesn't get a response back in, and then it's going to declare that the interface is in the edge state. But as it stands now with the default behavior, this interface here is not going to get rapid convergence. So if we did want to do that, we would need to manually set this under protocols, in this case protocols MSTP. So if we show config protocols, we would say go to config, go to edit MSTP, edit interfaces. Our interface is GIGI000, and we'll set no. I need to be under, let's go back to top, edit protocols, MSTP, edit interface, GIGI000.0, set edge. Okay, so this is the equivalent of the spanning tree port fast command then in Catalyst. If we commit and quit, then show spanning tree interface GIGI000.0 detail. We can see there's multiple instances because we're running MSTP, and also this is a trunk link, but it's a point-to-point edge port in for all of them. So if we were to flap the port on the other side and then look at the output for this, once it goes down, it would go from down immediately into the to the forwarding state. So same rules as Catalyst here, where Catalyst is calling it a port fast port. In the case of JunOS, it's an edge port. So then, like we see verification, that would be show spanning tree interface, and if we want to see the detailed outputs. Now, there are a bunch of other miscellaneous features that basically map on a one-to-one basis between JunOS and Catalyst. For example, in Catalyst, we have the BPDU guard that says, for some reason, this interface, we don't want to run spanning tree on it. If I hear a BPDU, then I want to disable the link. So this might be to like a shared office space or something like that, that you don't want people plugging into the network and either plugging in switches or potentially doing an attack on spanning tree where you could try to do a man-in-the-middle attack by declaring yourself as the root bridge. Or in the case of Catalyst, we call this BPDU guard. In the case of JunOS, this is BPDU protection. So in a global, on the EX switches, there's the category that is Ethernet-switching-options, and that's where we would define this BPDU protection. So we would go to config and edit Ethernet switching options, And if we look at what's under here, this would be things like MAC notification, .1Q tunneling. In this case, BPDU block is the BPDU protection, essentially. Storm control, this is where you would also do like a static ham entry. So static MAC address to belong to a particular port. Secure access port, this is the equivalent of port security in the case of the Catalyst world. But again, these are under Ethernet switching options. Okay, we also have then spanning tree root guard, which is a subset of BPDU guard in the Catalyst world, or a subset of BPDU protection in JunOS, that says I'm allowing spanning tree messages to come in, but if it's a superior BPDU advertisement, so someone is claiming themselves as the root bridge, then I'm going to disable the port. I'm going to put it into inconsistent state. Where in the case of Catalyst, this is the spanning tree guard root at the link level. In the case of JunOS, this is under protocols RSTP or under protocols MSTP under the interface, and then we say no root dash port. So we saw this. This is where I was configuring the edge ports. If we top edit protocols MSTP interface gig E 000.0 and set question mark, that would be no dash root dash port. And again here, what I'm doing here, jumping through the parser hierarchy, I was under root, then under root I was under protocols, and then I was under MSTP, and I said go to the top and then do an edit. So this brings me back to root, and then I'm going down to protocols, and then from protocols I'm going to, or actually no, I was under Ethernet switching options. So it was under root, under ETH switch. So from here I said go back to the top, then go to protocols, then go to MSTP, and then so on. This would have been the same if I was at top, I was at edit Ethernet switching, then I said top, then edit, and then whatever the submode is. But the difference here is that in the case of iOS, you can jump directly between whatever modes that you want. Like if you're under router OSPF1, you could say interface gig 1 and it jumps immediately there. In the case of JunOS, you have to strictly follow the parser hierarchy. So if you don't know exactly where it is, just go to top and then show. And you could see, just based on the indentation, specifically where is something located. So like system, services, DHCP, trace options, etc.